In 7.5, we're going to be talking about inverse circular functions or inverse trig functions. So we've got a lot of things to read to set this up. For a function f, every element x in the domain corresponds to one and only element, or y, in the range. Okay. Think about what we know about function. Remember in the past, this was a function, but this was not a function. In order to be a function, it had to pass the vertical line test. Okay, so think about that. It had to be passing the vertical line test in order to be a function. Okay, so from now on, we're just assuming that we're talking about something that is a function. Okay, something that does pass the vertical line test. If a function is defined so that each range element is used only once, then it is one-to-one. So we've also got this thing called one-to-one. And so if you look back at just your basic parabola, that's not one-to-one. Basically, this is a horizontal line test. Okay, so in order to be an inverse, we're going to have to be a function that is one-to-one, and so something's going to have to pass both the vertical line test and the horizontal line test. Okay? Any horizontal line will intersect the graph of a one-to-one function in at most one point. So one-to-one, it's got to pass the horizontal line test. So here's an example of something that does. X cubed passes the horizontal line test, but x squared does not pass the horizontal line test. Okay? The inverse function of the one-to-one function is defined as this, which I think is hard to read. It says all points yx such that the point xy belongs to the function. Basically, you might remember from past classes, college algebra or algebra 2, where we switch x and y. That was how we formed the inverse function in those other classes. So, a word of caution, the -1 is not an exponent. Okay, it gets confusing because if you look at a calculator, your calculator has a button like this. And generally what that does is if you hit the number 4 and you hit that button on your calculator, it just means 4 to the -1st power, which flips it. It makes that 1/4 or 0.25 comes out of your calculator. That is absolutely not what we are doing. Okay, the -1, and like when I say sine -1 x, okay, I wouldn't say sine -1 x. Okay, that's not what I would say. That's not an exponent -1. That means inverse. Okay, that means inverse sine. And so be careful and don't call that -1 an exponent. So a summary of inverse functions. In a one-to-one function, each x value corresponds to only one y value, and each y value corresponds to only one x value. That's your vertical line test and horizontal line test. If a function is one-to-one, then f has an inverse function. Okay, so it's kind of important that we're one-to-one. The domain of f is the range of the inverse, and the range of f is the domain of the inverse. Again, that's just reminding us to switch x and y. But we won't really talk about switching x and y. We'll be talking about domain and range. And it's going to be really important to think about the domain and the range of these functions. And I'll give you a chart later, and you'll be able to reference that chart. But it's going to be really important to look at domain and range. The graphs of the function and the inverse are reflections of each other across the line y equal x. And then down here is kind of how to find an inverse of a function. You can look at these 3 steps. But that looks more like what we did in college algebra. We won't be doing a whole lot of that. Okay. So then this next picture, BA is the reflection of AB. Again, they're talking about, in order to find the inverse, you're switching x and y. And here they're talking about the reflection. So if this was your function, they reflected it over the line y equals x to get this inverse function. Okay, that's not something that we will be graphing. We won't be really doing that. They're just trying to set this up and help you understand what an inverse is. Okay. Note, we often restrict the domain of a function that is not one-to-one to make it one-to-one without changing the range. Okay. So basically, when we look back at a function like this that wasn't one-to-one, this doesn't have an inverse. Okay, we can't work with this. We can't work with this, and so we're going to restrict the domain and basically just blank out part of the graph because we don't want it. Okay, we're only going to look at just half of the graph, and so that's when they say restrict the domain. We're only going to look at the right side of it, and so if you only look at the right side of it, then it's like, okay, now it's one-to-one. That's going to be really important for us as we look at trig functions. Because if you remember, when we graphed a sine curve looks something like this. That was one period of it, and if you go the other way, okay, and it goes on and on and on forever. It's periodic, that repeats itself. But it's pretty easy to see that's not going to be one-to-one, and so we're not going to be able to deal with that. That's not going to have an inverse, okay? Except what we're going to do is we're going to restrict the domain, and basically we're only going to look at like that, okay? We're going to restrict it and only look at part of the graph, and if you only look at part of the graph, now it is one-to-one. Okay, now it is one-to-one, and that part is going to have an inverse, and we're going to be able to deal with that. Okay, so that's what that slide was saying. We're going to have to restrict the domain.